So in this video we're talking about solving absolute value equations and inequalities. So first off, how does absolute value relate to distance? Well, absolute value is just simply the distance away from zero. And this is on a number line. And then what's the algebraic definition? All right, well, we have absolute value of x. That's got three pieces. So let's say x is 0. Then the absolute value of x is equal to 0. If x is equal to, let's say, if x is equal to a positive number, then it's just going to be x. And then finally, if x is negative, it's going to be negative x. So if x is less than 0. And these arrows should really be ifs. Sorry, excuse me there. Okay? So you need to know that. We'll talk about that later in the next chapter. And then how do we solve an absolute value equation? Well, essentially, we're going to use number lines. But we also need to get the absolute value piece by itself. So get the absolute value piece, I'm going to just say ADS by itself. Okay, that's going to be our first objective. Okay, so here, absolute value is already by itself. Now, the absolute value is the distance away from 0. So think about it. The distance away from 0 is 9. Okay, so let's draw a number line. Help us understand what's going on. So here's 0. Well, if I walk to the right, I can get to 9. Obviously, this is 9 units away. The distance from 0 is 9. That's one option. Okay. Well, if I walk to the left, I can also get 9 units away. So if I walk to the left, I'm 9 units away. The distance from 0 is 9. So this is 2x minus 5. This is 2x minus 5. Okay? And it all depends on which direction you walk. Case 1, I walk to the right. Case 2, I walk to the left. So let's do that. We have to split our problem up into two cases. So case 1. Case 1, I walk to the right. So when I did that, I saw that 2x minus 5 was equal to 9. Okay, well, let's solve this one. Okay, 2x minus 5 is equal to 9. So add 5 to both sides. So we have 2x is equal to 14. Divide by 2. So x is equal to 7. All right, now we need to look at the second case. So case 2, I walk to the left. Case 2, I walk to the left. 2x minus 5 is negative 9. Notice I'm not including the absolute value brackets. I took everything outside of absolute value. So add 5 to both sides here. So we had 2x is equal to negative 4. And so divide by 2 on both sides, so x is equal to negative 2. So depending on what's going on here, we have two solutions. Now, if we go back to the original equation, if we plug in these values, everywhere I see an x, I plug in a 7, I should get a true statement. Everywhere I see an x, I plug in a negative 2, I should get a true statement. That's because I have two possibilities for walking away from 0. I can walk to the right, I can walk to the left. Okay? Now, here, we're talking about absolute value inequalities. So we need to pay attention to the symbols. Okay? Here I have less than or equal to. So anytime you have a less than or less than or equal to, that essentially just means and. Okay, and what we're going to do is going to be ax plus b is less than c and greater than negative c. So you need to know this rule. That's just something you need to memorize, get it taken care of. Okay, for the second piece, or. This is an or, greater than or less than, greater than or equal to. That's an or. So we're going to have ax plus b is greater than c, or ax plus b is less than or equal to negative c. Okay? So you need to memorize those rules. Now, what has to be true about both the values for c? Well, distance away from 0, think about it. Distance, can distance ever be negative? No, so distance always has to be greater than or equal to 0. So C always has to be greater than or equal to 0. That means distance has to be 0, meaning you stay at 0, you don't leave your house, or it's positive, you're walking away. You can't have negative distance, doesn't make sense. Okay, so let's solve this. Hey, we have less than, that means this is an and problem. So that's an and. So I'm just going to split up I want to write my inequality now. So 2x plus 7 is less than 11 and greater than negative 11. Now I'm going to split it up into two inequalities like we've done before. So negative 11 less than 2x plus 7 and 2x plus 7 less than 11. Solve each one. Subtract 11 from both sides. So negative 18 less than 2x, divide by 2. So negative 9 less than x. Okay? And just bring that down. Subtract 7 from both sides. So we have 2x is less than 4. Divide by 2. X is less than 2. So this is our answer. If you're not sure, you can plug in both values. Plug in a value that's bigger than negative 9, so maybe negative 8. Plug in a value less than 2. There you go. Okay. So let's go on to another example. Notice I didn't graph it. We already talked about graphing in a previous video. Okay, so no need to do it again here. All right, so here I have greater than or equal to. So that's an or problem. So I have 3x minus 2 is greater than or equal to 8. Or 3x minus 2 is less than or equal to negative 8. That's just using that rule we talked about on the previous page. Okay. So now solve both of these, add 2 to both sides, so 3x is greater than or equal to 10. Divide by 3 on both sides, so x is greater than or equal to 10/3. Can't reduce the fraction, so I'm going to leave it like that. This is an or problem. Add 2 to both sides. So 3x plus 2 is equal to negative 6. Divide by 3. So x is less than or equal to negative 2. So this is my answer. So x is bigger than 10/3, or x is less than or equal to negative 2. Okay? That's it. Again, I'm not going to really do graphing because we already did that before. No need to repeat ourselves. If you're not sure about how to graph, go back and look at the previous video. And that's it for this video and for this chapter. Thank you very much.